It's a GATE question from the year 2025, set 1, question number 38 for 2 marks. A computer has two processors, M1 and M2. Four processes P1, P2, P3, P4 with CPU burst of 20, 16, 25 and 10 milliseconds respectively arrive at the same time, and these are the only processes in the system. The scheduler uses non-preemptive priority scheduling with priorities decided as follows. M1 uses priority of execution for the processes as P1 greater than P3 followed by P2 greater than P4. That is, P1 and P4 have highest and lower priorities respectively. M2 uses priority of execution for the processes as P2 greater than P3 greater than P4 greater than P1, that is, P2 and P1 have highest and lowest priorities respectively. A process Pi is scheduled to a processor Mk if the processor is free and no other process Pj is waiting with higher priority. At any given point of time, a process can be allocated to any one of the free processors without violating the execution priority rules. Ignore the context switch time. What will be the average waiting time of the processes in milliseconds? So this question is from the operating system subject from the CPU scheduling topic. So we have been given two processes M1 and M2, and the priorities for M1 and M2 are as shown, and also that the CPU uses non-preemptive priority scheduling. That means once a process is scheduled in the CPU, it cannot be forcefully preempted or forcefully removed. And we have four processes, all of which arrive at the same time. Assume that they all are in the system from time 0 onwards, and the burst times are indicated against each process. Now we have to schedule these four processes among or between these two processes as without violating the priority rules. So now check that initially both the processes are free, and let us assume that all the processes arrive at time 0. So let us say that the current time is at the 0th slot and we have all the processes arrived in our system. So for the processor M1, P1 is of highest priority and it is in the process. So we cannot schedule any process from P2 to P4. If any process can be scheduled in M1, it has to be P1, and the burst time for P1 is 20. So this will be there in the system until 20 units of time. Now check, M2 is free and the highest priority process is P2. So we cannot have any other process P3 or P4 scheduled to M2 when P2 is already in the system and is waiting for allocation. So the first process scheduled in M2 can be P2 with running time 16. Now, since this is non-preemptive, we cannot forcefully remove any processes, so they will be in the system until they complete their burst time. Now check, we have two processes remaining, P3 and P4, and which processor to which processor should we allocate these. Now P3 has second priority in M1 and it will be loaded to M1 from 20 unit of time. But check, in M2 also P3 has the next higher priority and this processor is free from 16th. So when the time stamp is 16th, you check P3 and P4 both are waiting and the highest priority process next is P3. So P3 will get scheduled in M2 and will run for 25 units of time. So this should be 16 plus 25, that is 41. And now check, at the 20th timestamp, you have just one process P4 waiting. So obviously there is no question of priority here. It has to be scheduled because no other process is waiting anymore. And this gets executed for 10 milliseconds and before it finally concludes. Now let's see what's the completion time. So P1 completes at time 20. P2 completes at 16. P3 completes at 41. P4 completes at 30. Now the turnaround time is computed as completion time minus arrival time. So for this amount of time, the process will be in the system. Either it is waiting or it is executing. So this is 20, 16, 41, 30. And the waiting time is calculated as turnaround time minus burst time. So this is 0, 0. Process P1 and P2 have 0 waiting time. And this is 41 minus 25, that is 16. It was waiting for 16 units of time before getting the CPU. And this is 20. So the total waiting time is, you sum all these, it's 36. And average is, you divide this by number of processes, that is 4, which is equal to 9. Hence the answer to this question is 9. Thank you.